let's start with the magnetic circuit. Okay, so first of all, this magnetic circuit, from this magnetic circuit in Manipal, questions will come mainly. Okay, as you have seen that in every module 3 question will come, but for the magnetic only 2 question will come. Okay, one is of the different category, one is of the different category, maybe 4 plus 3 marks, or maybe 3 plus 3 marks. Okay, so generally the magnetic circuit came of 6 marks. Got it? Now the first category question is like, suppose we'll have two coils are connected in series. Okay, two coil means it is inductance. This inductance, self inductance is L1, right? And the second self inductance is L2, and the mutual inductance between the coil L1 and L2 is denoted by M. Okay, got it? So these are two coils, both are connected in series. We'll represent it by dot convention. Dot convention means if both the dots are at the end starting side, that means current is entering. I'm telling you separate also. If there is a inductor and dot is on the starting side, that means here current is entering. Okay, and if the dot is on the leaving side, like suppose here, that means current is leaving. Got it? If it is on the starting side, that means current is entering, and if it is on the ending side, that means current is leaving. So if both the dots are on the starting side, or if both the dots are on the leaving side, then technically this connection is known as series aiding connection. Okay, this connection is known as series aiding connection, and for the and the formula for that L equivalent means total inductance would be L1 plus L2 plus 2M. L1 is the self inductance, L2 is the self inductance of the second coil, and M is the mutual inductance. So this formula you are going to use in the numerical. Write it down. The second category, that is series opposing connection, that was in series aiding connection. Next is series opposing connection. If the two inductor are connected in series, but both the dots are at the opposite side, means one is at the entering, another one is at the leaving. Similarly, we'll have one at the leaving and one at the starting. Okay, L1, L2, L1, L2. So in this case, L equivalent is how much? That is L1 plus L2 minus 2M. Okay, if it's series aiding, then it is plus 2M, and if it is series opposing, then that would be minus 2. Note it down this way. We'll use one more formula, that is K is equal to M divided by root of L1 L2, where K is the coefficient of coupling. Okay, this we are going to use in the numerical, these three formulas. Let's do numerical based on that. This is from your app. Yeah, coefficient of coupling. This is from your paper 2019. See, in this question they said effective inductance when two coils are connected in series is found to be 10 Henry. Means L1 plus L2 plus 2M is equal to 10. When terminals of one coil are reversed, means L1 plus L2 minus 2M is equal to 6 Henry, right? If the coefficient of coupling means K is equal to 0.6, you have to calculate the value for L1, L2 and M. Now tell me how can we'll have another formula. K is equal to M root L1 L2, right? K value is given, but we don't know M and L1 L2, right? This is one equation. It's L1 multiplied by L2, not plus. Both equations we can add it with each other. Okay, if we'll add these equations with each other, then we'll get 2L1 plus L2 is equal to 16, right? Because plus 2m and minus 2m is cancelled out with each other. L1 plus L2 is equal to 8, right? Then after that, we'll get the relationship between L1 and L2, right? Or we can subtract with each other. Tell me. See, in this question, this is your paper question. They have given the circuit like this and they draw the dotted equivalent circuit. Since there are three inductors, right? L1, L2, L3. Here the current is entering. Here also the current is entering, right? And here the current is. So now we have converted the dotted convention. Then it would be easy, right? They have given the mutual inductance. That mutual inductance between 1 and 2 is J3 ohm. Between 2 and M2 is J5 ohm. No. Sorry. Yeah, this is how I change it in the dotted. The coefficient of coupling is given, right? That is K1, 2, K2, 3, both are 0.7, 0.7. K1, 3 is 0. Now you need to calculate, determine inductance individual. This one is L1. This one is sorry, they didn't give you L, they gave you XL because they have mentioned it's ohm and they mention frequency also. Frequency they have given as 50 hertz. Okay, so as you know, XL is equal to omega L, correct? And omega L is how much? Pi FL. So instead of giving you the L, they gave you XL because they have mentioned it over here now. Ohms means it is XL. So if they have given J3 ohm, so J3 is equal to pi into 50 into L. So J3 divided by 100 pi, that would be your L1. Similarly, J5 divided by 100 pi, that would be your L2. J6 divided by 100 pi, that will be your L3. Got it? So in this we get L1, L2, L3, and mutual inductance we can get it by this formula. K is equal to K12 is equal to M12 divided by root of L1, L2, right? Mutual inductance we need to calculate. K12 they have given in the question, L1, L2 we can get it. So we can substitute all the values, then we'll get L equivalent. Got it? Okay, this is a question from your paper only. This question also from your paper only, and this question also from paper only. These three coils are connected in series. They have given L1, L2, L3 K value, and you need to calculate the total inductance. Total inductance L equivalent is equal to L1 plus L plus L3 plus 2M1, 2M2, 3 and M3, 1. Okay. All these are questions from your paper only. and definitely you'll get one question from these types of. Okay, if you have any doubt, then you can contact me on this number. Bye bye.